All right, let's start with a pretty wild idea. What if the very same chemical that helps grow your food could also power an entire continent? That's the huge, kind of counterintuitive bet that East Africa is making right now. And really, this is a story about building economic independence, one single molecule at a time.
So that brings us to the big question, right? Can fertilizer actually fuel a continent's future? The answer, it seems, is a resounding yes. And how they're doing it? Well, it's a fascinating story of some serious strategy and innovation. Okay, to really get why this radical shift is happening, we first need to understand the problem that East Africa is so desperately trying to solve. This is all about breaking free from what people call the fossil fuel curse and the incredibly high price of that global energy dependence. Right now, many East African economies are what are called price takers. That means they are totally at the mercy of these wild swings in global oil prices. A conflict happening thousands of miles away can make the price of fuel just skyrocket overnight, and that can cripple everything from public transport to local businesses. It just creates this constant state of economic vulnerability. And that impact isn't just at the gas pump. Check this out. Any disruption in the global supply of natural gas, which is the key ingredient for traditional fertilizer, can cause prices to jump by a staggering 5 times. Now, in a region where farming is literally the backbone of the economy, this isn't just some inconvenience. It is a direct threat to food security and the livelihoods of millions of people. So the region is really facing a stark choice, as you can see right here. On one side, they can keep relying on imports with all the volatility and uncertainty that comes with it. Or on the other side, they have a chance to build this kind of shield of energy sovereignty, one that's based on local production, price stability, and some real economic resilience. And the bridge to this much more stable future is a molecule that's actually surprisingly familiar: ammonia. But hang on, we're not talking about your standard ammonia. We're talking about something totally new, a green, dual-use version that just changes the entire game. So what in the world is green ammonia? Well, let's just follow the process here. You start with renewable energy. Think geothermal or hydropower. That energy powers a machine that splits water into hydrogen. Then you take that green hydrogen and you combine it with nitrogen that you literally just pull from the air around us. The result is NH3, green ammonia, a really powerful carbon-free molecule. And this table just shows the contrast so clearly. On the left, you've got your conventional, or gray, ammonia. It relies on natural gas, which ties its price and its massive carbon footprint directly to fossil fuels. But then, look over at the green ammonia column on the right. Its feedstock, just water and air. This completely decouples production from those volatile energy markets, and it gives you a near-zero carbon footprint. And here's the kicker. Its application is dual use. It's both a fertilizer and a clean fuel. So you might be thinking, well, why not just use the green hydrogen directly? And that's a great question. The answer really comes down to physics and cost. As you can see, to transport hydrogen as a liquid, you have to get it down to an insanely cold minus 253 degrees Celsius. But liquid ammonia? It only needs to be cooled to minus 33. That huge difference in temperature makes ammonia way cheaper and easier to store and transport, which is an absolute game changer when you're trying to build out new infrastructure. Okay, so we've got the molecule. Now let's talk about how you actually move it. This is where the really ambitious part kicks in. It requires building these massive new green corridors of power, the whole infrastructure for this new era. All across East Africa, major ports are being completely transformed. Look at the key players here. Lamu in Kenya is getting ready to become a major green ammonia production hub. Mombasa is set to be a bunkering station, kind of like a green gas station for ships. And Dar es Salaam in Tanzania is becoming this critical link in an electrified rail corridor. I mean, these aren't just shipping hubs anymore. They're the gateways to a whole new energy economy. And if the ports are the gateways, then these modern standard gauge railways, well, they're the arteries. The line that's already running in Kenya and the new electrified line in Tanzania will be the main channels for moving green ammonia from the coast to the interior and for connecting renewable energy production out to global markets. But this grand strategy of ports and railways, it's not just about big infrastructure. It has a really powerful, direct impact on people's lives. Let's take a look at the revolution that this is creating right down on the farm. This chart really highlights a massive opportunity. Farmers in sub-Saharan Africa use, on average, just 17 kilograms of fertilizer per hectare. Now compare that to the global average of 135. That is a huge gap. And it's not because of a lack of will, it's because of high costs and unreliable supply. Just closing that gap would be a monumental step in boosting the whole region's food security. So the key to closing that gap could be this incredible concept, distributed green ammonia, or DGA. Instead of these giant centralized plants, this means building small modular facilities, 1,000 times smaller, located right where the fertilizer is actually needed. And this isn't just some theory. A commercial plant from a company called Talus Egg is already up and running in Naivasha, Kenya. And the benefits of doing it this way are pretty straightforward. First, you slash costs because you get rid of transportation, which can be up to half the price of fertilizer. Second, you empower farmers, letting them form cooperatives to secure their own supply. And third, you create this amazing synergy, linking local renewable energy directly to water management and food production. It's a closed loop. And this quote from the Ethiopian government, it just says it all. When the vast majority of your people are farmers, making your own fertilizer isn't just some economic policy. It's a matter of national security. But let's be real, achieving this kind of sovereignty is not easy, and it is certainly not cheap. We have to be realistic about the pretty significant costs and the challenges that are still ahead. There are 3 really big hurdles. First, the upfront capital cost is enormous. We're talking billions of dollars. Second, there are technical risks. Ammonia is a toxic substance, and it requires highly skilled people to handle and transport it. And third, we just can't ignore the environmental impact of massive projects like Lapset, which will need some very, very careful planning to protect vital ecosystems. Then there is this idea of the green premium. And yeah, right now it does cost more to produce green ammonia than its fossil fuel cousin. But this isn't just a cost. You have to see it as an investment. It's kind of like buying an insurance policy. You pay premium now for guaranteed stability in a world of totally unpredictable energy prices. So when you boil it all down, the ultimate goal is crystal clear. It's about building a buffer that protects the region's economies from all these global shocks and allows them to build a future that's based on true macroeconomic resilience. Which leaves us with one final very big question. By leveraging its own renewable resources to secure both its food and its fuel, is East Africa actually creating the blueprint for a new, truly sustainable industrial age for the entire continent? It's a bold vision, and you can be sure the rest of the world is watching.